Section 5.5 is called Multiplication of Polynomials, and Part A is multiplying a monomial with a polynomial. We skipped Section 5.3 in the textbook. Section 5.3 is all about operations with monomials, and one of the things that you do in Section 5.3 is multiply two monomials together. Here's an example of that. Multiply 3x squared y times 2x y to the fourth. Using the commutative property of multiplication, I can rearrange the order of all of these things that are multiplied into any order that I like. So I'm going to choose to order them so that the numbers come first, then the x's, and then the y's. This gives me 6x cubed y to the fifth. That's really all there is to multiplying monomials together. Sometimes the number in front is negative, or it might even be a fraction. Sometimes you have one variable, sometimes you'll have two or even three. But basically, you just need to multiply the numbers together, then the x's, then the y's, then the z's if there are z's. Of course, they can have any letters in them. The variables could be s or t, p or a, but the principle is the same. Multiplying two monomials together just means multiplying the like factors. 3 times 2, x squared times x, and y times y to the fourth. We're going to use this in Part A of 5.5, multiplying monomials with polynomials. Because multiplying monomials with polynomials means multiplying a monomial times a polynomial one term at a time. For this example, using the distributive property, I can multiply 3x squared by 2x to the fourth and 3x squared times 4x, and so on. So all I'm doing here is distribution, except that the thing I have in front that I'm distributing is more than just a number. It's a whole algebraic expression. Using distribution and writing an intermediate step that you may not need, this would give me 3x squared times 2x to the fourth plus 3x squared times 4x plus 3x squared times 5. Then I can use this trick to simplify. This will be 6x to the sixth plus 12x cubed plus 15x squared. So all I've done here is multiply two monomials, which is why I went back and had a look at section 3.3, multiplying monomials. That's what we're doing here, so I wanted to reinforce what that really means. If you need more practice multiplying monomials, have a look at section 5.3. Part A is multiplying monomials, and parts B, C, and D cover other operations. So read Part A if you need a little extra practice with this idea. And then you could also try some of the problems in the Part A section of the homework. Your textbook only has one example for Part A, multiplying monomials with polynomials. So I'm going to do a couple of examples from the even questions in the exercise set. This is question number 2. Multiply 4x times 2x minus 3. Just using distribution, this gives me 4x times 2x minus 4x times 3. Using the commutative property, I could rewrite this, but remember we don't have to. These are all multiplication, so I can just go straight in and think 4 times x times 2 times x is the same as 4 times 2 times x times x. So this is going to give me 8x squared minus 4 times 3 is 12 times x. This is my answer for this multiplication problem. I'd like you to see another technique because your textbook introduces it, but it doesn't do so until a little bit later in the section. I think it's easier to introduce it at this point so that you have a choice and you understand what's actually happening. In section 5.4, when we were adding and subtracting polynomials, your textbook introduced a column method there. By stacking like terms, we could just add them up like we were doing an addition problem. We can also use this for multiplication. With multiplication, we don't need to stack them like with like. If I did, my 4x would be over here. But if I had a multiplication problem like 30 times 3, I could write that as 30 times 3, and then do my multiplication. Multiplying polynomials this way, I have 4x times negative 3. Let me first change this to plus a negative to make that a little easier to see. 4x times negative 3 is negative 12x. And then 4x times 2x is 8x squared. And I get the same answer either way. Here's another one. Multiply 5x times the polynomial 4x cubed minus 5x squared plus x. Using distribution, I get 5x times 4x cubed minus 5x times 5x squared plus 5x times x. Simplifying, I have 20 x to the 4th minus 25 x cubed plus 5x squared. Using the column method, I'll write my long polynomial on top and multiply it by the monomial 5x. 5x times x is 5x squared. Positive times a positive is a positive. 5 times 5 is 25, and x times x squared is x cubed. A positive times a negative is a negative. 5 times 4 is 20, and x times x cubed is x to the 4th. A positive times a positive is a positive. Of course, I don't need this leading positive sign. My answers match. They should. I've used two different ways to multiply, but I've multiplied the same two things, so I should get the same answer. Here's my monomial. I want to multiply this by all three of the terms in the polynomial here. 6xy cubed times 2x squared plus 6xy cubed times 5xy plus 6xy cubed times 12y squared. And then simplify. Numbers first. 6 times 2 is 12. Then letters. X to the 1 times x to the 2 is x to the 3. And y to the 3 times, well, that's the only y factor, so I just need to copy it down. Plus 6 times 5 is 30. X to the 1 times x to the 1 is x squared. Y cubed times y to the 1 is y to the 4th. Plus 6 times 12 is 72. X to the 1 times, there's no other x factor, so just x to the 1, or just x. Y cubed times y squared is y to the 5th. So this is my final answer. 6xy cubed times this polynomial is this polynomial. We've removed the parentheses in the same ways we did using distribution with just a number in front. So really we've already done this. This is a combination of the distributive property of multiplication over addition and multiplying monomials using rules for exponents.